So hello guys, here we have question number 4 from Check Your Understanding exercise of the chapter Ray and Wave Optics from Pathfinder. So let's look at the question. A silvered ball of radius r equals to 5 cm is so suspended that its center is h equals to 1 meter above the floor and s naught equals to 2 meter horizontally away from a person of height h naught equals to 2 meter. There is also a large plane mirror which stands vertically at some distance from the person. If the person sees his image in the ball as small as sees his image in the plane mirror, how far is the plane mirror from the person? If you want to solve it without the hint, please do it now. So if you want the hint, here it is. A person perceives size on the basis of the angle subtended at his eye. So if you want to try it with the hint, you can do it now. So now let's look at the solution. So first of all, as I said, a person perceives the size of the object on the basis of angle subtended at his eye. So let's first of all consider the case of plane mirror. Let's say the man is of object h naught as given in the question. Then his image will be of the same height h naught, which will form at a distance of 2x, and I've assumed that it is at a distance x from the plane mirror. So from here, what we get is, and let's assume that it makes an angle theta 1 at the eye of the mirror. The theta 1 will be made by the ray coming from the bottom point, and it will reflect at the mirror at the midpoint by symmetry, and it will come here. So it is the angle theta 1. So tan theta 1 equals to h naught by 2x from the right angle triangle. And we will find later in this question that theta 1 comes out to be very small quantity. Tan theta can be approximated to theta 1. So from here, what we get is theta 1 is equals to h naught by 2x. Now let's consider the case of reflection through the ball. So now here, consider the following rays. First ray is coming from the bottommost point, and it will go in the eye of the observer after reflecting at the exact midpoint. Let's call it B, and this comes by symmetry. And the second ray will be the ray going from the eyes of the man to towards the center of the sphere, and they will reflect back along the same path, and they will again go in his eyes. So the angle perceived by the man will be theta 2, and now we need to find angle theta 2. Now here let's assume that this angle is theta and the other angle is beta theta 2 as we assumed, and here let's drop a perpendicular from B to the line a b dash. So this is the perpendicular. So from here what we get is AB is approximately equal to AB dash first of all, which can be found by Pythagoras theorem to be AO whole squared plus OB whole squared. So from here, which will be h naught by 2 whole squared plus h naught minus r whole squared, and so AB minus theta 2 will be equals to BB dash by the arc length equals to r theta, and from here BB dash can be found from the triangle from the perpendicular we dropped on AB dash. What we get is BB dash equals to r sine alpha from the triangle, and sine alpha is equals to AO over AB. So from here what we get is theta 2 equals to r times AO by AB squared. Now here AO is h, and AB squared will be h naught by 4 squared plus h naught minus r squared. Now here we can observe that h naught minus r is approximately equals to s square, h naught square. So from here we get the value of theta 2 to be 4r h naught over 2 times h naught square plus 4 h naught square. Now equating these two angles theta 1 and theta 2, as we are given in the question that they are supposed to make an same angle at the eye of the person. So from here what we get is h naught by 2x is equals to 4r h naught over 2 h naught squared plus 4 h naught squared. So finally what we get is x equals to h naught square plus 4 h naught square over 4r, and on substituting the values you get the value of 100 meter. So yeah, that's the final answer. Thank you.